Hello students, please take a moment to mark your test so you know which problems you need to correct. Press pause now and then press play when you've marked the test right or wrong. Please make corrections to ones you didn't understand even if you happen to have guessed right, and correct the ones you got wrong. I am planning to go as quickly as I can to get through the test. You may need to run the video back to listen again or zoom forward to get past problems you understood and got right. Please use a color for your corrections and write down the work on your test to receive a higher grade. Number 1, which situation best represents a constant rate of change of 60 miles per hour? The first thing I'm going to write is that 60 miles per hour, and that means 1 hour, 60 miles in 1 hour. So we're trying to see which one of these matches this 60 miles per hour. Well, I need to put the miles on top and the hours on bottom for every one of these. And then let's divide to see which one is 60. So 150 divided by 2 is 75. 180 divided by 2 is 90. 200 divided by 4 is 50. And 300 divided by 5 is 60. And that one is exactly the same speed, constant rate of change. Number 2, the triangles below are similar. Which segment corresponds? On M and O corresponds to BC. Corresponds means matches up with. And so we're trying to see which part matches up with BC. Well, the first thing I need to do is redraw one of these triangles. I'm going to redraw the small one. And I notice one of these angles is 51, and then there's a 51. 85, but I don't see an 85 over here. This one says 44, and this one is missing an angle. What if this was 44? And what if this was 85? I wonder if that would add up to 180. 85, 51, and 44. When you add those up, sure enough, it adds up to 180. So these angles are exactly the same. The sides are proportional, which again is the definition of similar. So I need to turn this around so that this has an 85 degree angle so that those two angles match. These two are both going to be 51, and these two are both going to be 44. So now the 44 degree angle is A. I'm going to label this A. The 85 degree angle is B. I'm going to label 85B. And the 51 degree angle is C. So now I'm finished with this. I have redrawn it over here, and so I scribbled it out because I don't need it anymore and I don't want to be confused by it. We're trying to see which one matches up with BC, which is this top part right here. Well, it would be this top part of the other triangle, NO. So segment NO is right there. Number 3, which table has a constant rate of 2.5? So when I look at these problems, from 1 to 3, that's a change of 2. From 3 to 5, it's a change of 2. From 5 to 7, it's a change of 2. But look what's happening here. From here to here, it's an increase. It's going up. But then from 1.8 to 1.5, it's going back down again. And 1.5 to 1.7, it's going up again. So this is definitely not a constant rate of change. When you look at these, it's a change of 1 every single time. And when you look here, it's a change of 3, and then a change of 2, and then a change of 3 again. So again, this side is a constant 1, 1, 1, but this side is not a constant rate of change. C, it's changing 1, and then 1, and then 2. Here, so we could just look at this part right here. Since it's 1, 1, let's see if this is the same. This is a change of 1, and this is a change of 0.5. So even though this is the same, this is not the same. So that's not a constant rate of change. So I've eliminated these 3 answer choices. It's probably D. Let's take a look. It's a change of 1, change of 1, change of 1. Here it's a change of 2.5, and then 2.5 again, and then 2.5 again. The x's are constant and the y's are constant. And rate of change, like it says in your notes, it's the change in y over the change in x. Well, the change in y is changing 2.5. X is changing by 1 each time. Well, 2.5 divided by 1 is 2.5. So this is a constant rate of change of 2.5. So that's exactly the one we're looking for. Number 4, the elevation at ground level is 0 feet. The elevator starts, and I'm going to draw a bar diagram to show the elevator going up and down. Ground level is 0 feet. Then it says the elevator starts at 90 feet below ground level, so that would be negative 90 feet. It's 90 feet underground. After traveling for 15 seconds, now the elevator is 20 feet below ground level. So it's very close to ground level, but it's still underground. So it's negative 20 feet now. So it started here and it went up, and it took 15 seconds. And so it's a change of 70 feet. Now, it's asking for which statement describes the elevator's rate of change during that 15 seconds. So they're asking for this time period right here where it went up 70 feet in 15 seconds. And look at your answer choices. The elevator traveled feet per second, feet per second, feet per second, feet per second. So let's write that down. Feet per second. This should help us figure it out. It traveled 70 feet up. That would be plus, positive 70 feet. Traveled upward. It did not travel downward. So it cannot be C or D. And it took 15 seconds to travel. And so this bar, this fraction bar, tells us to divide. 70 divided by 15. 15 does not go into 7. 15 goes into 70 4 times. 4 times 15 is 60. We're subtracting it 10. Now, looking at your answer choices, it's either going to be 6 or 4 and 2/3. So let's write our final answer as a fraction. 4 and 10/15. Let's simplify the fraction, divide by 5 on the top and the bottom. So that would be 4 and 2/3. So sure enough, 4 and 2/3 feet per second is our answer, and it's going up. So B is the right answer. Number 5, determine which table contains only values that satisfy. In other words, x's and y numbers that make it true, where the y does equal half of x minus 8. And so I'm looking at these tables. All of the x's have the same numbers, -10, -5, 0, 5, and 10. And I think that it would be nice if we could plug in some numbers, and let's choose a number to plug in that's an easy number to calculate. Let's use 10. 0.5 times 10 is going to be pretty easy. And when I look at these choices, the 10 is the same on all the tables, but the y number is different. And so if we'll plug in 10, then hopefully we'll get one of these numbers and not the others. And so that would help us to figure out which one is right, which one is, all the others would be wrong. So I'm going to plug in x is 10. X is the 10 number. X is 10 in each table. So y equals 0.5 times 10 minus 8. Anytime you multiply by 10, it moves the decimal once. So 0.5 times 10 is 5. And 5 minus 8, you could do keep, change. 5 plus negative 8. The signs are different, so we would subtract and take the sign of the higher. So y would be negative 3. So it's looking like this is the right answer. When x is 10, I got y is negative 3. Let's try one more. Let's plug in 0. We've got 0 as x, and so let's give that a try, because multiplying by 0 is going to be really easy, and we can check and make sure that D is the right answer. Plug in x is 0. So y equals 0.5 times 0 minus 8. Y equals, anything times 0 is 0, and 0 minus 8 would be negative 8, or you could think to yourself, keep, change. 0 plus negative 8, and 0 plus negative 8 would be negative 8. So here we've got a negative 8. So D is the right answer. Now I see negative 8 here, but this number is not right. It's not 0, 0, it's not 0, positive 8. So it is definitely D. Number 6, each sprinter on the team is required to complete 1 1/4 mile during their practice every day. And so it tells you this conversion right here, 1 mile is 1,600 meters. The question is, how many 200-meter sprints would that equate to? So they're asking for how many 200-meter sprints it is. But they told you 1 1/4 mile. So the first thing you need to do is convert it from miles to meters. And so I'm going to take this conversion right here, 1 mile is 1,600 meters, and I'm going to write that first. 1 mile, I'm going to use mi for miles, and 1,600 just m by itself for meters. So if I set the first ratio at miles over meters, I need to set the second one at miles over meters. And so now I need 1 1/4 mile. 1 1/4 mile is 1 1/4. And we don't know how many meters that is. Well, 1 1/4, if you'd rather use a decimal, that would be 1 2500 miles. And so now if I cross multiply 1.25 times 1,600 and 1 times x is just x, and I'm going to bring down the equal sign. And over here I'm going to do 1,600 times 1.25. Remember, at the beginning you pretend like it's 1,600 times 125. 5 times 0, 5 times 0, 5 times 6, 5 times 1 plus 3. Now you need a placeholder. I'm going to cross off the one that I carried. 2 times 0, 2 times 0, 2 times 6, carry the 1. 2 times 1 is 2, plus 1 is 3. Now I need 2 placeholders. And I'm going to cross off that one I carried. 1 times 0, 1 times 0, 1 times 6, 1 times 1. 8 and 2 is 10, I'm carrying a 1. 6 and 3 is 9, plus 1 is 10, and 1 and 1 is 2. So now there are 2 numbers to the right of the decimal. On 2, I have to have 2 numbers to the right of the decimal in the answer. So I have to choose to put my decimal right there. So it's the number 2,000. And so what I just figured out is that it's 2,000 meters. So they have to run 2,000 meters every day. The question is, how many 200-meter sprints is that? You could work this out several different ways. I like to think about a picture. The total is 2,000 meters. They're going to run a 200 meter, and then another 200, and then another 200. And so we are splitting into parts. And splitting something into equal parts is dividing. 2,000 is being divided into 200-meter sprints. So 2,000 divided by 200, you might be able to do this mentally. but I'm going to go ahead and work it out. 200 does not go into 2. 200 does not go into 20. 200 into 200, yes, 1. We subtract and get 0, but we have to keep going until we get to this decimal. So there is another 0 here. 0 times 200 is 0. So it's 10. 10 200-meter sprints. Number 7, which conditions must be met for two triangles to be similar? Well, the definition of similar is that angles are congruent. That means the angles are exactly the same. And the sides are proportional. So if we think about a small photograph of a person and you enlarge that photograph, and it's still the same person, but it's just larger. If you think about the angles, they're both rectangles. So this rectangle has 90-degree angles, and this rectangle has 90-degree angles. They are both 90. So the angles are exactly the same. The side lengths are not. The side lengths are proportional. So if this was 1 and this was a length of 2, this would be 3, this would be 6. So 1 over 2 is the same as 3 over 6 because this represents half and this represents half. Or you could think to yourself, times 3 times 3. 1 times 3 is 3, 2 times 3 is 6. So yes, they are equivalent. Sides are proportional. So you just need to be very careful to read your choices. Angles are proportional? No. Angles are unequal? No. They're exactly equal. Angles are congruent? Yes. Angles are congruent? Yes. Corresponding, well, we've already determined these two are completely wrong, so let's just look at the other two. Sides are proportional? Yes. Sides are equal to each other? No, the sides are not. You've got shorter sides and longer sides. So it has to be C.